Did you hear the news? Astronomers wielding the biggest telescope ever invented, the Event Horizon Telescope, managed to take a snapshot of the monster black hole at the center of our Milky Way galaxy. Today, I'm going to take you on a deep dive into what this means for our understanding of matter, gravity, and our galaxy itself. Let's go into the impossible. If you're new to my channel, welcome. I'm Brian Keating, the Chancellor's Distinguished Professor of Physics at UC San Diego. I'm an experimental cosmologist who builds telescopes and takes them all around the world, from the South Pole to Chile to California, and even to far-flung places like outer space. Today's announcement literally shook up the world, not only for professional astronomers like me, but for amateurs, lay people, every curious human being just like you. The Event Horizon Telescope was constructed in the past 10 years, and in 2019 made a stunning announcement, the first ever image of the so-called event horizon of a black hole. Black holes are the most mysterious objects in the universe. They've been awarded multiple Nobel Prizes for discoveries ranging from LIGO to the theoretical underpinnings of their mathematical structure to Sir Roger Penrose. We've even seen images in the optical and near-infrared thanks to telescopes run by Andrea Ghez and Reinhard Genzel using adaptive optics in the infrared wavelength regime. Today's press conference shook up the universe. It showed magnificent images that shed light, pun intended,
you're a funny guy,
on the most mysterious objects we know about. These black holes are the subject of great controversies, perhaps responsible for our deepest understanding of how gravity can be unified with quantum mechanics. Black holes have implications for the destruction of information, something that's forbidden by quantum mechanics. They have relevance to thermodynamics, to entropy, and even our understanding of time. Sometimes black holes are even thought to be the source of dark matter in the universe, although we've known for quite some time that black holes can't contribute very much to the amount of dark matter there is in the universe. Even the most massive black hole that we've ever imaged using the Event Horizon Telescope in 2019, the black hole at the core of M87, which weighs in at a whopping 2 billion times the mass of our sun.
M87's huge black hole mass makes it really a monster.
That black hole is dwarfed by almost 1 trillion more stars in M87. The black hole only represents about 0.1, 0.2% of the mass of that particular galaxy. And the same is true of the Milky Way galaxy that today's results pertain to. Galaxies like the Milky Way actually orbit not because of the black hole at their center, but because of the vast amount of dark matter, which far dwarfs the amount of black hole mass in our galaxy. In past interviews with Heino Falke and Shep Dolman on this channel, we discussed the phenomenon of the so-called light shadow or event horizon, which was discovered by the same team using the same telescope array. A series of radio telescopes ranging from the South Pole Antarctica, called the South Pole Telescope, to the neighbor of the Bicep Telescope of Antarctica, all the way to Chile and other telescopes throughout the planet, constructing a planetary-sized telescope that allows scientists with very small wavelengths, millimeter wavelengths, to image the black hole and its properties. Now, M87 is about 60 million light years away in the Virgo cluster. It's a behemoth with 1 trillion stars, 5 times as many as the Milky Way galaxy. And the black hole at its core is about 2 million times the mass of our sun, and the black hole in the Milky Way galaxy, called Sagittarius A star, discussed in today's press conference, is only quote unquote about 6 million times the mass of our sun. So there's almost 500 times more mass in the galaxy called M87's black hole than in the Milky Way galaxy's black hole, which is why they probably made that discovery first, and that announcement came in 2019 as opposed to 2022.
On those scales, the black hole itself is minimally small.
Now, the benefit of Sagittarius A star is that it's closer to us, and astronomical signals often decay as the inverse square or sometimes even higher powers of the distance from the object to the observer here on Earth. The smaller size of the Sagittarius A star black hole meant that light traverses it in a much shorter amount of time, far, far shorter than the time that it would take for light to traverse the black hole in M87. Meaning that in just about 20 minutes, you could get many images of how the dynamics of this black hole are changing. You could effectively make a movie because of the black hole's compact size. You couldn't do this with M87, as cool as that was. Upcoming results, in combination with the infrared images of Sagittarius A star from Andrea Gheze's group and Reinhard Genzel's group, make for an amazing so-called multi-messenger astronomical extravaganza. We're using multiple wavelength range, each providing a unique fingerprint, a Rosetta Stone contribution, if you will, whatever metaphor you like, to better understand the properties of gravity, of space-time's radical curvature at these behemoth size scales.
Yes! Come on!
What an amazing time to be alive, as an utterly new window on the cosmos is opened, thanks to stunning new technology like adaptive optics, polarization sensitivity, and very long baseline interferometry using a planetary-sized telescope. You can watch the whole press conference at the link in the video description below. I've also had conversations as an experimentalist with the leaders of this Event Horizon Project telescope. Now, these team leaders that I've conversed with, including Shep Dolman and Heino Falke, provide amazing insight into what it's like to actually build this technology and operate it, and not least of all, analyze the data from it so that we truly can understand what gravity behaves like in the most extreme circumstances in the known universe. So let me know in the comments, what black hole do you think the Event Horizon Telescope should turn its powerful eye to next? Check out this playlist combining my conversations with phenomenal, brilliant theorists like Delilah Gates, like Kamran Vafa, and with Juan Maldacena about the properties of black holes and what they teach us about entropy, time, dynamics as well.